Yesterday we looked at simplifying and multiplying rational expressions. Today we're going to go one step further. We're going to work with dividing and finally solving. To start off, let's refresh our memory since fractions are rational numbers and take a look at remembering how we divide fractions. If you recall, you take a look at a relationship between fractions. You're really multiplying by the reciprocal. So I'm going to start by rewriting this as 6/8 multiplied by 32 over 12. And then I see that 6 and 12 have a common factor of 6. 6 divided by 6 is 1. 12 divided by 6 is 2. I see that 8 and 32 also have a common factor of 8. 8 divided by 8 is 1. 32 divided by 8 is 4. Which means when I clean this up, I get 4 over 2, which is equal to 2. The other way that you could possibly see these is looking at it with a fraction within a fraction. And this simply, remember, means when we have this giant fraction bar here, this simply means divide. So with that being said, I'm just going to rewrite this initially as a division problem, like this one up here. We have 36 over 45 divided by 16 over 27. Then I can rewrite that by keeping the first fraction as is, 36 over 45, and multiplying by the reciprocal of 27/16. Then I can go through and notice that 45 and 27 have a common factor of 9. 27 divided by 9 is 3. 45 divided by 9 is 5. 36 and 16 have a common factor of 4. 16 divided by 4 is 4. 36 divided by 4 is 9. So now I can go through and multiply out, and I get 27 over 20. You could change that to a mixed number. For the purposes of our class, we're just going to keep it improper. The next type we're going to look at is starting to get into rational expressions. We have here x squared minus 36 all over 8 divided by x cubed minus 6x squared over x squared plus x. The first thing that we're going to do is to change the problem by multiplying by the reciprocal. So when I rewrite this, I have x squared minus 36 over x. I'm going to change it to multiplying by x squared plus x over x cubed minus 6x squared. The next thing I want to do is to factor everything possible. So when I do that, I realize that x squared minus 36 is a difference of squares. So I have x plus 6, x minus 6. Obviously I can't factor the bottom, so I will leave it x. And x squared plus x, I can factor out an x, which leaves me with x plus 1. And then on the bottom, I can factor out an x squared, which leaves me with x minus 6. My third step then is to cancel only after we're done factoring. And I see that we are done factoring. And I have an x minus 6 and an x minus 6. And I have an x and an x. And I don't see anything else that I can factor. So my final step then is to clean up that final answer. Remember, when everything on top we multiply together, everything on the bottom we multiply together. I look and I see that on top I'm left with x plus 6 and x plus 1. And on the bottom I'm left with x squared. If you would like to FOIL out the x plus 6, x plus 1, you can. It is not required by any means, and in fact, I would almost prefer it to be in factored form. Looking at our next example, we have x minus 4 over x minus 2, the quantity squared, divided by x squared minus 3x minus 4 over x squared minus 4. So I'm going to start by rewriting it by multiplying by the reciprocal. We have x minus 4 over x minus 2 quantity squared. We're going to multiply that by x squared minus 4 over x squared minus 3x minus 4. And then we factor as much as we possibly can. I see here x minus 4 can't do anything, but on the bottom I'm going to split apart that x minus 2, the quantity squared, into x minus 2 times x minus 2. It'll make for easier canceling of the x minus 4 on top. On the top, x minus squared minus 4 is a difference of squares, so that's x plus 2 times x minus 2. And then on the bottom, I need two numbers that multiply to negative 4, add to negative 3, which I find to be negative 4 and positive 1. So x minus 4, x plus 1. Now we can cancel. I can cancel the x minus 4 with the x minus 4, and the x minus 2 with an x minus 2. And you see that what's left over cannot be combined, which leaves us with a final answer of x plus 2 on top and x minus 2 times x plus 1 on the bottom.